Okay, we're going over the open book test, Unit 3.3 and 3.4 of Calculus, and the directions are to identify the open intervals on which the function is increasing and decreasing. Okay, to determine whether it's increasing or decreasing, what do we do?
You find the critical number.
So we do the first derivative test to find the critical numbers. So that's going to be where f prime is 0 or undefined. So when we find where the derivative is 0 or undefined, we'll find those critical numbers, which then we can divide into intervals, and we can check to see if it's positive or negative within that interval, and that will determine whether or not it's increasing or decreasing. So the first thing we want to do is to find the derivative of the original function. And so we're going to rewrite this function as a product. We're going to write it as x squared times x plus 1 raised to the negative 1 power. And when we do that, to take the derivative, we realize we have multiplication, and then we have a parenthesis, and a parenthesis creates a chain. So we're going to apply the multiplication rule and the chain rule. So to find the derivative, we'll have y prime is equal to what? How do you do multiplication? It is the first times the derivative of the second. So on the derivative of the second, we will have the derivative of the wrapper, which will be exponent negative 1 times the base of x plus 1, and then we reduce the exponent by 1. But then we have to say, because of the chain, times the derivative of the guts, which will just be the coefficient of x, which would be 1. Now that's just the first half. That was first times derivative of second. So now we have plus the second, which would be x plus 1 raised to the negative 1 times the derivative of the first, and the derivative of the first would be 2x. Okay. Now, we take the opportunity here to factor out common factors, and we have an x plus 1 that we see that appears twice. And we know that for each base, we take the smallest exponent, and negative 2 is smaller than negative 1. And then we also have a base of x, and the smallest exponent on that is that understood exponent of 1. We could choose to take off this negative. Sometimes we like to take negatives off. You may want to take it off. You may not want to take it off. But it is something we could pull out. It's not really a common factor. It's just a factor you could pull off of it. So we may just wait on pulling that off this time. We'll have y prime is equal to. So we're going to pull off an x and an x plus 1 to the negative 2. So we're going to leave that negative there. So when we pull that off, what we have left is one of the x's from here and the negative 1, so we have a negative x. And what we're going to have from here is just a 2. Oh, excuse me. What we're going to have left is one of those and the 2. We pulled out an x to the negative, an x plus 1 to the negative 2. We want to think x plus 1 to the negative 2 times what will give us x plus 1 to the negative 1, and it would be an x plus 1 to the positive 1, because when you multiply with like bases, you add the exponent, so negative 2 plus 1 would add up to negative 1. And that's always handy, because in this process of factoring, after we use the product rule, we always end up with a factor of whatever that little binomial was to the first power, which makes it kind of drop the parentheses automatically, which is nice. But we have this little sum right here multiplied to 2, and the rules of distributive tell us then we would need to put that back in parentheses so that we can distribute that 2 through it. Okay? All right. So we're going to have then y prime is equal to x times x plus 1 raised to the negative 2. And then we're going to have a negative x and a 2x, which gives us a positive 1x, and then a 2 times 1 is 2, so a plus 2 in there. Now, when we use the negative exponent to reciprocate, then we're going to have y prime is equal to, the x stays on top, the x plus 2 stays on top, and the x plus 1 raised to the second goes to the bottom because of the negative on the exponent. So there's the simplified version of the derivative. Now, we're looking for, what do we call those things? Critical numbers. Critical numbers are the values at which the derivative is undefined or 0. Now, what would make the derivative 0? Good. If the numerator is equal to 0. And what would make it undefined? If the denominator is equal to 0 or you have the square root of a negative number, right? Okay. So what would make the numerator 0 would be x times x plus 2 equals 0. We set the numerator equal to 0. And what would make the denominator equal to 0 is if we had x plus 1 quantity squared equals 0, if we wanted to show our work. It's obvious to us then that an x equals 0 would produce a 0 there. An x equal negative 2 would produce a 0 there. A negative 1 for x here would produce a 0, which would create an undefined situation. So we have critical points at negative 2, negative 1, and 0. What that does is it gives us test intervals. Okay? So I'm going to erase the top so we can kind of take a look at those test intervals. So I'm going to move, I don't want to get all that out of the way. I'm just going to get the middle out of there. And I'll put that up here. Okay, so that creates, these are our critical numbers. And so we're going to have the intervals from negative infinity to the least of those critical numbers, negative 2, and then from that critical number to the next least critical number, negative 1, and from that critical number to the next critical number, 0, and then from there into positive infinity. So we have 4 intervals in which the function may be increasing or decreasing. To determine whether it's increasing or decreasing within that interval, we just need to choose a number within the interval. We could choose negative 3 within this first interval, so we would want to do f prime of negative 3. If we chose a number within the second interval, then we would choose f prime of, we could choose a negative 1.5. If we chose within the third interval, we could choose something like f prime of negative 1/2. And in the fourth interval, we could choose something like f prime of 1. So when we determine those values, it will tell us whether it's increasing or decreasing within that interval. So we're going to plug those values into the derivative function. Okay? So what we need to do is just determine what? Whether it's positive or negative. So we're just going to plug them in kind of in our head and figure positive or negative. And so if we plugged in a negative 3 right here, we're plugging into here negative 3, we have a negative 3. That would be a negative 3 plus 2 is a negative 1. So you would have a negative times a negative, which is a positive, over. If you plug in a negative 3 here, you'd have negative 3 plus 2 is, 1 is negative 2 squared is a positive, because a negative squared is a positive. But here we have a positive over a positive, which is a positive. If the derivative is positive, then what does it tell you? It's increasing. The function is increasing within that interval. Okay? So if we plug in the negative 1.5 into our derivative function, we're going to have a negative there, a positive there. A negative times a positive is a negative, over a negative in the bottom. 1.5 squared will be a positive. A negative divided by a positive is a negative. If the derivative is negative, then that tells us that the function is decreasing. Okay. The negative 0.5 is going to give me a negative times a positive is a negative over a positive, which is negative. Therefore, we know that it is still decreasing. If I plug in a 1, I'm going to get a positive over a positive, and a positive over a positive is a positive, and so that tells me that it is increasing. And so we've done what it asked. We wanted the open intervals in which it's increasing or decreasing. So in the interval of negative infinity to negative 2, we found that the function is increasing. In the interval of negative 2 to negative 1, we found that the function was decreasing. In the interval of negative 1 to 0, we found that it was decreasing. In the interval of 0 to infinity, we found out that it was increasing. We should have the idea that increasing is going to look like this. Decreasing is going to be doing that. Here, we were going from decreasing, which is going down, to decreasing more, so it's still going down. It may have changed inflection, so there may be a point of inflection, and then from here to here, it's going from a decreasing to an increasing. So we should know from our other studies that there's going to be a relative max here. We didn't have to talk about that. There's going to be a relative min here, and here there would be a point of inflection, okay, in that graph. Any questions on number 1? Okay. Number 2 says, find the critical numbers, if there are any, and then find the open intervals on which it's increasing or decreasing, and then apply the first derivative test to identify all relative extrema, which we really just did. But we're going to go ahead and take it that far on this particular problem. So what do we need to do first? We need to find all the critical numbers, and how do we do that? Find the derivative and set it equal to 0, or find where there would be zeros around the find. So my derivative, f prime of x, would be 2x plus 8, a little bit simpler derivative than the last one. So we want to think about where would this derivative function be equal to 0 at, right? And so we would subtract 8. I got a little ahead of myself there. We would have 2x is equal to 8 divided by 2, and x is equal to 4. Negative. Thank you. So at x equal negative 4, we have a critical number. So that means that my test intervals are what are my test intervals? Negative infinity to negative 4 and negative 4 to positive infinity. So we have 2 test intervals. Okay, so we want to choose something within that interval, right? So we're going to do f prime of something within there, which we could choose negative 5. And we could do f prime of something within this interval, which would be like a negative 3, or we could just choose 0. That'd be easier to deal with. Okay? And so we're going to plug those into the derivative function. So in place of x here, we would replace that with a negative 5. So 2 times negative 5 is negative 10, which is bigger than 8, so that would be a negative value. We're just really trying to determine positive or negative. We have a negative something, and so that means that it is decreasing. If we plug in a 0, 2 times 0 is 0 plus 8 is 8, that's positive. Therefore, we know that it is increasing. We know that the function went from within this interval decreasing to increasing. Therefore, at the negative 4, there must be a relative minimum. Now, it wants us to identify the relative extrema. Now, it's asking then for an ordered pair. Negative 4 something. How do you get the something? How do you get the y that goes with that x of negative 4? We're talking about... Go ahead. Do we use f prime or f?
Or f.
See, we're talking about what's going on the regular function, right? This is the graph of x, right? We're talking about finding a minimum value on the original function itself. Now we use the second derivative to find the x, but to get the y that goes with it, we have to go back to the original function, right? So we're going to have to take that negative 4 and plug it into the original function. So we would have negative 4 squared plus 8 times negative 4 plus 10. So we're actually finding f negative 4, not f prime negative 4, right? So we're going to have 16 minus 32 plus 10, which would be negative 6. And so we have identified that there is a relative minimum at the point negative 4, 6. Any questions on number 2? Okay. So we get a lot of stuff going. Sometimes we're dealing with the original function. We're dealing with f prime. We're dealing with f double prime eventually. And you got to remember, what am I trying to do? The actual minimum or maximum value is on the original function, and so we plug back into that. So be careful with what you plug back into. All right, any questions on number 2? All right, number 3. So we want to do the same thing. So we can do this as a quotient. You want to do the quotient rule or the product rule? Product's usually easier. We usually do if we have the opportunity. So we're going to change this to x times x plus 1 to the negative 1. Most people choose, when possible, to use the product rule. And so we're going to have f prime of x is, now remember on the product, we now have a multiplication, and that parenthesis creates a chain. So we're going to take the first x times the derivative of the second. So we do the wrapper times the guts, right? Derivative of the wrapper times the derivative of the guts. The derivative of the wrapper would be exponent times the guts. Reduce the exponent by 1 times the derivative of the guts, which would be a 1, which is the coefficient of x, and we know the derivative of 1 is 0 there. So that was just the first part. That's first times derivative of second. And then we're going to have plus second, which is x plus 1 to the negative 1 times the derivative of the first, which is just a plain old 1. What are we going to do now?
You're going to pull out
Good.
Perspective.
So we're going to look at factoring opportunities. Good. So we see a common factor of x plus 1, and we take the lowest exponent, -2. There's not a common x, so that's all we can pull out this time. So we're going to have f prime of x is, we pull out that x plus 1 raised to the -2. And what we have left here is an x and a -1, so a negative x. It's also a positive 1, so -1 times 1 is -1 times x is -x. And then remember that if we took this times x plus 1 to the first, when you multiply with like bases, you add the exponents. -2 plus 1 is -1. And that keeps happening every time, that we just end up with that base of x plus 1. And so we're going to have a plus x plus 1. And if that had been anything besides 1, we would have needed to put that x plus 1 in parentheses and distribute it, but that 1 is going to keep it the same. So we can just leave it like that. Okay? These go out. This goes down. So we're going to have f prime of x is that 1 right there, because the x's went out, over, because this goes down, x plus 1 to the second power. Okay? Let's see how we got that. All right. Now, to find our critical numbers, we want to find where the derivative is 0 or undefined. And there's not going to be a 0, but we would get an undefined at x is equal to -1. That would create a division by 0 error. So that's my only critical number. Which creates test intervals of -infinity to -1. And now, we want to do the first derivative test. And what's the first derivative test checking for?
Increasing or decreasing.
Increasing or decreasing by finding out whether the first derivative value is positive or negative within that interval. So we're going to find the function, the f prime value within this first interval, and -2 would be in that interval. And we're going to find the f prime value in the second interval, and 0 would be in that interval. We're just trying to determine positiveness or negativeness. And so we're going to take this -2 and we would be plugging it in right here. That would be a -2 plus 1 is a -2, but when you square it, it's going to be positive, right? So we know that that's going to be positive. So we have a positive 1 over a positive something. That means it is increasing. If we plug in a 0, we would have a positive 1 over positive 1. Still going to have a positive over positive, which is positive. And so it is also an increasing. It's going from increasing to increasing. I'll highlight to kind of show you. It's going to be going from increasing to increasing. All we've done somewhere in that point of -1 is we've changed concavity. My values of y, my values of the derivative are still going up, 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 up. So it's increasing in both. Therefore, at that point, there is no relative extrema, right? There's no relative maximum. What we have there is a point of inflection. Now, on a test, we would want you to go through this and talk about increasing, and then we would want you to say there is no relative extrema. No relative extrema. Okay. Any questions on number 3? All right. Now this gives us a trigonometric function, and it gives us an interval in which to work with, because you could just keep going on forever with that. So we have to have some closure to that. So don't forget that we are working within a specific interval here. So I don't want that to slip from our mind. Now we want to find the derivative. So we have f prime of x is. Now this is the derivative of a sum, which would be the sum of the derivatives, right? What is the derivative of x? Would be that coefficient 1. Now, this is a coefficient rule, right? Which would be 2 times whatever the derivative of sine x is. It's not a product, it's not a chain, it's just plain old 2 times the derivative of whatever sine x is. And what is the derivative of sine x? Cosine x. So it's 2 times r2 cosine x. Okay. So there's the derivative. Now, to find the critical numbers, what do? We set it equal to 0. So we'd have 1 plus 2 cosine x is equal to 0. Now we need to isolate the cosine x and then think the cosine of what is what. Okay? So we're going to get the junk off of cosine x. So we're going to subtract 1. So we're going to have 2 cosine x equal negative 1. Divide by 2, we're isolating cosine x. So we have cosine x is equal to negative 1/2. Now at this point, we go to our memory work. We have that they're all positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. Cosine is positive in quadrant 4. And my interval is from 0 to 2 pi. So I'm going to go all the way around. Now, so from memory we think, what the cosine of what is 1/2?
60.
Good. It's 60 degrees, which is pi over 3. So we're thinking about having pi over 3 in the first quadrant, or the second quadrant, or the third quadrant, or the fourth quadrant, right? As our reference angle. But then we have to think, well, cosine is negative. This is a negative 1/2. So we think, well, where's cosine negative at? Well, cosine is positive in first and the fourth, so we would need to be in quadrants 2 and 3. So whatever these are the places that give us that 0, right? We're thinking the cosine of what is negative 1/2. Well, this is going to be 1 whole pi. In terms of 3's, it would be 3 pi over 3, right? And this is, so this one would be 1/3 less this one. Right? The top one, I'm sorry, here on the bottom. The top one would be 1/3 less, which would be 2 pi over 3. And this one on the bottom would be 1/3 more, which would be 4 pi over 3. Good. Okay, so my critical numbers are going to be at x equals 2 pi over 3, and x is equal to 4 pi over 3. Very good. There's my critical numbers. Now, that creates for us test intervals. So my test intervals are going to be from
0,
negative infinity to 2 pi over 3, and then 2 pi over 3 to 4 pi over 3, and then 4 pi over 3 to infinity. We're going to need to determine the function, the derivative value of something in that interval. We don't want to choose goofy stuff. We want to choose stuff we know from memory, right? So when we make a choice, let's make wise choices. So we're going to have f prime of something that we have memorized that's from 2 power over 3 to infinity. So what's something between there that we have memorized? I would choose a quadrantal angle. So if we want to be in there, we just say pi isn't. Oh, we want to be smaller than that, right? So pi over 2. Pi over 2 is a quadrantal angle, you see. Yes. So I would choose quadrantal angles. Pi over 2. Or pi. Or 2 pi over 3. Right? I'm sorry, 3 pi over 2. That was weird. 3 pi over 2. Because then you get ones and zeros. They're easy to do it. Or undefined, right? So we're going to choose within that interval. We want to be smaller than that. So we would use a pi over 2. That would be an easy one to deal with. Over 2. Okay, in that second interval, what would be an easy one to choose? Somewhere between there. Well, the quadrantal pi. There you go. F prime of pi. We're just choosing easy values. We could have made it harder on ourselves. Come on. And then we want to be between 4 pi over 3 and the other end, which is 3 pi over 2. So quadrantal angle right in there. So F prime of 3 pi over 2. And then we're just trying to figure positiveness or negativeness, so we can figure increasing or decreasing. So my derivative was this, right? I've got to plug back into this. So I'm going to plug in a pi over 2. So we think, well, what's the cosine of pi over 2? 0 or 1?
It's 0.
0. Good. So 0. So 0 plus 1 is 1.
At this time, we
That
need all
is-
seniors for a meeting in the gym, please. We need all seniors
Positive.
in the gym.
So the increase.
Therefore, it's increasing. I'm running out of room there. Let me move some stuff and write above it here. I think I can just get rid of all of that. So looking at my critical numbers, I'll put the values above. Okay, so this one was positive, therefore it's increasing. Okay, so pi, if we plug in a pi, what's the cosine of pi? Negative 1 times 2 is negative 2 plus 1 is negative 1. So this one is negative, therefore it's decreasing. Good. And then what is the cosine of 3 pi over 2?
0.
0 again. So it'd be 1 again. So it's positive again. So it's increasing. So we know that here it went from increasing to decreasing, so there's a relative maximum at 2 pi over 3 something. And here it's going from decreasing to increasing, so there is a relative
Students also upward bound. Representatives are in the library. If you need to see them during breakfast, if you're in upward bound, stop by the library, or if you have applications ready to turn in, they will take those in the library during breakfast.
So there is a relative minimum at 4 pi over 3 something. Now remember, to find those somethings, we're actually talking about the value of the original function, right? So these we have to plug back into the original function. So we would plug this into here. So we're going to say, well, what is the sine of 2 pi over 3? Well, what's the reference to 2 pi over 3? 60. What's the sine of 60?
Square root of 3.
Square root of 3 over 2. Excuse me, that was weird. square root of 3 over 2 times 2 over 1 plus my x, which is 2 pi over 3. Now, we're talking about quadrant what? 2 pi over 3 is in quadrant 2. What about sign there? Positive. So that's a positive, so all that's positive. Okay? Now, so these are going to cancel. So we're going to have 2 pi over 3 plus square root of 3. Okay? All right, now we'll plug it in over here. So we're going to plug this in. So we're going to have the sine of 4 pi over 3. Now that's in quadrant 3. So that makes sine negative. So it's going to be negative square root 3 over 2 times that 2 plus that 4 pi over 3. And these are going to cancel. So there you're going to have 4 pi over 3 minus square root 3. All right. So we have determined the open intervals. We found the critical numbers. Oops, I'm sorry. We found the critical numbers. We found the open intervals. We determined increasing and decreasing. From that, we determined that there were relative maxes and mins at those particular critical numbers, and then we plugged those back into the original function to get the y values of those critical points. Any questions on number 4? All right, thank you very much. We'll start number 5.